Good. Great, there are still so many here, even though you don't have a, what is it called, assessment today? Very good. Yeah. So, first of all, Magnus has asked me to look at component diagrams quickly, because it was a bit unclear, so I'll just make a short example directly in Papyrus. Then I will get to sequence diagrams. I have a couple of things to add here, but otherwise I'll just show how you get them into the program, basically. And then I'll talk about code generation. So how do you get code out of your class diagrams, hopefully in a way that you can use it and don't just get lots of conflicts and problems and so on. Let's see how I manage time-wise. All right, component diagrams. Let's just create one. So this is kind of the easy introduction, short repetition. Components, and let's directly create a component diagram. Good. I think maybe the biggest problem with component diagrams is to understand what a component represents, because in most programming languages there is not really a representation of a component. So class diagram, you know what a class is, you know what a method is, you know what an attribute is, but you don't know what a component is necessarily. Or it's a word that is used everywhere. Everything is somehow a component, but what does it actually mean? So generally it's a way to encapsulate your system. So you could say something like, I have one component that's my hotel, for instance, or my hotel system. Meaning everything you do in this project is in here. So in terms of programming, this box here will just be your system, nothing else. That would be a component. Now, one example we did last year, which I think was quite clear, at least what it meant, is that we added a bank to this. So that was some kind of component, some kind of piece of software that represents a service that a bank offers. And, well, there was an interface in between. Basically, the bank offers some kind of functionality, your hotel uses it. What kind of functionality could this be? Well, I guess all of you in your project, you have some kind of, well, when you do a booking, you have to register your credit card. Or when you check out, you have to give a credit card number so the payment can be made. That was basically this thing here. Because the hotel doesn't write down the credit card and throws it away, but it wants to get the money. And for that, it has to talk to a bank. But the hotel, or you in that case, you're not anyone that writes banking software. That's completely out of your scope and you're not interested in that. But you still need it if you would write a proper system. So, this is some kind of external software, some external service that you use for getting your functionality to run. Similar, let's make an example that you probably all know. If you use the Android Maps application, you could see that as a component. But it doesn't really work without the Google Maps API. And you could see that as an external component. So the Google Maps API offers some kind of functionality that your system uses. Now, if you would write an app that shows a map, most likely you would use this if you're on Android. That's an external component. You could also take your system and break it down into multiple components. So for instance, you have one component that handles everything that has to do with navigation. You have one component that handles, I don't know, persistence or calling someone. So it's just a logical separation of stuff. In your case, you could say you have one component that does all the administration. or it does all the room bookings, and you do one component that does customers, for example. So generally it's just a logical separation that later on is not that easy to see in the software, maybe. If you write a simple app, that's not a big problem. If you write a system with 1,000 developers, that gets a bit more interesting. And that's the main idea of components. Now, I removed this just to make a bit clearer what this is actually. And I said last time that you need to have something in between here, which is called an interface. And usually it's called something like provides, bank provides, or bank provides. That basically shows this is some kind of functionality that this component provides to someone. And this component implements this or realizes this interface. And then you could have, like in a usual interface, you define operations. For example, you say, make payment. You can call this method, send in a credit card number and an amount, and this functionality makes sure that if the credit card is valid, there will be a payment made. And the main idea is here that you need to know this method, but you don't need to know anything about the implementation. So imagine the same in a company. You have 20 teams working on the software. You could say each team gets a component, and the other teams only know this interface. They only know if I want to make a payment, I call this. They're not interested in what's in here. So that's really separation. And quite often it's separation by organization structure. You have different teams. Or by functionality. You have the team that works on the banking part. You have the team that works on the room administration part. You have the team that works on the customer administration part. That's basically this. This will be a very boring start in the screencast. Good. I'll quickly show how to get it in there. Well, you create a component diagram, as I already did here. So you see that down here. And then you can create components. Now I need my properties view. So for example, let's say this is my hotel system. And the other one is my bank component. And then I somehow want to communicate that with them, so I can create an interface here. Bank customer provides. And add an operation. For example, make deposit. And well, make deposit should have some nice attributes like a credit card number, amount, something like that. And the hotel system will use this component, whereas the bank will implement this. That's basically all I can say for this. One more thing that is interesting is that you can have multiple interfaces. So a bank can have two different interfaces. And what I did last year is that I called this bank administration provides. And here you could have something like create credit card accounts. So what I did here is basically I have two different interfaces here. This is the one I will give to my customers. You can use this interface for making deposits, for checking whether a card is correct and so on. And this is the interface that I will use for my internal stuff. For example, if you go to the bank, I would like to have a new bank account, then they will use this to create a new bank account. But this interface shouldn't be visible outside so that no one can start creating accounts or adding money or whatever, removing money. Right? So there shouldn't be a connection from here to here. That would be somehow wrong. And last year we basically had a third component that was testing. And then from the testing you were allowed to create accounts and so on. So you can have multiple interfaces for one component, but they should have a. That's the whole point. Interfaces should have a certain purpose. You shouldn't just have interface and then 30 methods in it. Then it's the question: do they make sense or not? For example, again, hotel system. You could have an interface that does all the room stuff. You could have an interface that does all the booking stuff, or so on. So they should somehow make sense, not just here's my hotel interface. But that's more a design issue, not the syntax. Good. Any questions for component diagrams? Great, then let's close it. Now I'll be talking about sequence diagrams, and of course now you know all what they are about. Here I drew a sequence diagram, and that's incredibly easy to read. Let's see whether I can zoom in. Oh, that was not very helpful. Anyway. Ooh. That's already a bit better. So, here I am, Grisha, and I'm a teacher. And here we have students. Or we have one student. I don't give that student any name. And hopefully you receive my lecture content. So I'll tell you something and it arrives. Someone asked about the lost message earlier. So here we have one and you can't see it. Let's see whether I can move it. No, of course not. Ha, here we go. Hopefully I don't say anything and it ends up somewhere. So it should end up here. So this is kind of the bad case. That would be an example for a lost message maybe. And then maybe I'm very happy if I get questions. So I will be happy to receive questions from you. And then of course I will answer them. Finally, and here comes the synchronous stuff. I think I just crashed my Papyrus. Anyway, finally of course I can ask you a question. And then I will make sure that I wait until I get an answer. So I don't say, how are you doing? And then I continue talking. But I say, how are you doing? And then I wait and wait and wait until the lecture is over, maybe. So this is the difference, right? And that's what we've discussed before. You can have something, if you have this synchronous stuff here, it's blocking. You wait until you get an answer. If you in Java call a method, you will wait until you get the return. If you open a website, you enter the address, press enter, you can do tons of other things while the website is loading. That would be more the asynchronous up there. I'll just reopen this. This looks funky here. Yeah.
Excuse me, are you recording the lecture?
I am, yeah. So everyone can see later on how I crashed my Papyrus. I'll just quickly restart Eclipse. Boom. While this is loading, we had a bit of a discussion here before the break of what is useful to show on sequence diagrams. And I think that's a very nice discussion. I like that one. Magnus said is a bit the telecommunication view. If you have a protocol, the idea of a protocol is to show which order do messages come. First you send the whatever request, then you get an ACK at some point. You're not as much interested in the exact details, what's happening in each of these messages, or what's happening in the process of computation or whatever. So this is more of a order view. What comes first, what comes second. And for that, the single messages like this is very, very useful. What you could also imagine is that you're very interested in this stuff here. How long does something happen? And then the synchronous stuff could be much more useful, right? So imagine you have you have some kind of contract. So contract in the legal sense. You have some customer, and let's call him developer. And, well, the customer sends in something, request, a development request. Says, here I have a very nice idea, please develop this for me. Then everyone knows at some point you will get an answer. At some point there will be yes, no, we'll do this, we don't do this, or whatever. But you could be very interested in what exactly is happening in here. How long does stuff happen? So you could say, well, first we need to have an internal discussion whether this makes sense. When we're done with that, we might have to ask our boss, we might do something else. And we know that, and this is syntax that you probably don't need to know, but you can say something like, well, this discussion typically takes 1 week. And then, well, the boss, he's always saying he's busy, he's not really working, but we get a reply after 3 weeks, we know that. So you could be very interested in these, this period takes that long, this period takes that long. While we are discussing, nothing else can happen, and so on. This is a different view on it. And then at some point you'll say, yes, of course. So it really depends on what you do with the diagram. And that's really important to understand, that there is no true or false, there is no right or wrong. Depends on what you want to show.